Every time you park your car and turn the key, a war begins. Not with a bang, but with a silent, creeping wave of heat.
It's called heat soak, and it's the intense, unmanaged thermal stress that happens after your engine shuts down. According to the U.S. Department of Energy, trapped heat can raise underhood temperatures by up to 50 degrees Fahrenheit.
Baking your components long after you've walked away. I've thermally mapped over 200 different engine bays to diagnose these hidden failures. And what I've seen is a pattern of destruction that starts small and ends in catastrophe. We're going to count down the 7 ways this thermal warfare is silently killing your car, ending with a failure that can silently erase $30,000 from your bank account. Number 7. Plastic sensor brittleness. You get a check engine light that comes and goes, a random stumble, or a weird idle. You pop the hood, and everything looks fine. Here's the thing. The plastic components in your engine bay are in a constant battle with heat.
They endure thermal cycling from 50 degrees on a cold morning to over 220 degrees Fahrenheit when the engine is hot. Over years, this heat literally boils the plasticizers out of the material and oxidizes the long polymer chains that give plastic its flexibility.
Manufacturer technical service bulletins, especially for vehicles in hot climates, document this embrittlement process. The fix starts with a $20 sensor, but a shop will charge you $150 for the diagnosis and replacement. The real problem is when that brittle plastic shatters.
During removal and pieces fall into your intake manifold. Now you're looking at a $500 repair to fish them out.
I had a 2018 Jeep Wrangler from Arizona in the shop with just 60,000 miles. I went to unplug the map sensor, and the connector literally turned to dust in my hand. It looked like brown sugar crumbling away, proof that 5 years of desert heat had won the war.
The problem doesn't stop there. It gets into the very metal of your engine.
Number 6. Exhaust manifold stress fractures. You shut off your car, and a few minutes later you hear it. A faint, sharp tick, 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 coming from the engine bay. That's the sound of metal fatigue. Here's the thing.
Your cast iron exhaust manifold can reach over 500 degrees Fahrenheit under load. When you shut the engine off, it cools rapidly. This constant extreme expansion and contraction creates microscopic stress inside the metal's crystalline grain structure. Over tens of thousands of cycles, these micro-stresses connect, forming a hairline crack. Data from major automakers shows this is one of the most common non-maintenance repairs. After the powertrain warranty expires, you might get away with a $250 gasket job if that's all that's leaking. But a cracked manifold replacement is closer to $750. And if you ignore that ticking, the crack widens, and the bolts holding the manifold can shear off inside the cylinder head. Now you're looking at a $2,000 job.
To drill them out. I've seen a Ford F-150 where the tick was so faint, the owner ignored it for a year. By the time it got to me, a tiny crack had become a 1-inch gap, glowing cherry red after a test drive.
And sounding like a machine gun under the hood. And just when a mechanical failure seems manageable, the damage becomes electrical.
Number 5. Wiring harness connector failure. The problems are ghosts. Your radio cuts out on bumpy roads. A warning light flickers for no reason. The car refuses to start one day, then works perfectly the next. Here's the thing. Every electrical connection has a tiny amount of resistance.
As heat from the engine bay rises, that resistance increases, which in turn generates its own heat. This creates a vicious feedback loop, called ohmic heating, where a connector gets hotter and hotter over thousands of drive cycles, eventually deforming the pins or melting the plastic housing itself. NHTSA fire investigation reports frequently point to degraded electrical connectors as the origin point for engine bay fires. A single connector repair can be $200. If the heat damages the main engine harness, you could be looking at a $3,000 replacement. But if that connection shorts and starts a fire, You're looking at a total loss of the vehicle.
I once spent 3 days chasing a ghost in a beautiful BMW 7 Series. It turned out the main connector to the engine control unit, buried deep under the cowl, had slowly melted from years of heat exposure. The plastic housing looked like melted wax and smelled of acrid, burning electronics, a silent fire that was slowly killing the car's brain. If you've ever worried about what's happening inside your engine after you turn it off, hit that like button.
The reality is, what you can't see is what costs you the most.
Number 4. Turbocharger oil coking. Your turbocharged car feels sluggish, like it's struggling to breathe. The boost comes on late, or not at all. Here's the thing. When you shut down a hot, turbocharged engine, the oil inside the turbo's bearing housing stops circulating.
With no coolant or oil flow, residual heat from the exhaust turbine soaks into the center cartridge, cooking that trapped oil. At temperatures exceeding 400 degrees Fahrenheit, the oil literally cracks its hydrocarbon chains, turning into hard carbon deposits.
This process is called coking. Technical documents from turbo manufacturers like Garrett and BorgWarner explicitly state this is the number 1
cause of premature turbo failure. If you catch it early, a specialized cleaning might save it for $400. Ignore it, and you're looking at a $2,000 turbo replacement. But if that failed turbo sends metal fragments through your intercooler
and into your engine, it's a $5,000 catastrophe. I pulled a turbo from a Subaru WRX with only 40,000 miles. The oil feed line was completely blocked with a substance that looked and felt like gritty, black asphalt. The turbine wouldn't spin at all. It was seized solid by carbon, all because of improper hot shutdowns. But if a $5,000 repair bill is steep, wait until that same price tag applies to a single component. Number 3. Automatic transmission fluid breakdown. You notice a slight hesitation when the car shifts, a subtle shudder. Or maybe the shifts just aren't as crisp as they used to be. The enemy here is heat, again.
Your automatic transmission fluid isn't just a lubricant, it's a hydraulic fluid that operates clutches and cools the unit. But for every 20 degrees Fahrenheit increase above its normal operating temperature of about 175 degrees, the fluid's life is cut in half. According to papers from the Society of Automotive Engineers, sustained high temperatures cause the fluid to oxidize. It becomes acidic, losing its lubricating properties and forming sludge that clogs tiny passages. A simple fluid change is under $300. Let it go, and you'll burn out the clutch packs, leading to a $5,000 transmission rebuild. But if that sludge starves the valve body and planetary gears of lubrication, you're looking at a total failure,
requiring an $8,000 brand new unit. I had a Honda Odyssey come in that the owner used for towing a boat every summer. The fluid, which should have been bright red, was dark brown and smelled exactly like burnt toast. That smell is the signature of thermal breakdown, and it was the warning sign of a transmission that was just weeks away from total failure.
That's when the damage becomes irreversible, and the costs enter 5 figures.
Number 2. Cylinder head warpage. You get a sudden overheating warning. White smoke pours from your exhaust. You check your oil, and it looks like a chocolate milkshake. This is the end game of thermal warfare.
Here's the thing. A single clog in your cooling system, a bit of scale, a failing thermostat, can create a localized hotspot on your engine's cylinder head. You could have one part of the head running at a normal 220 degrees Fahrenheit, while another section, starved of coolant, skyrockets to over 300 degrees. This uneven expansion exerts immense mechanical stress
across the massive 50-pound block of precision-machined metal. According to data from engine remanufacturing facilities, this is a leading cause
of head gasket failure. The head physically warps, breaking the seal. Catch it the moment it happens, and you might get away with a $2,500 head gasket job and head resurfacing. If the head is cracked from the stress, it's a $4,000 replacement. Wait too long and coolant mixes with your oil, destroying the engine's bearings.
Now you're facing a $10,000 engine replacement. I've laid a straight edge across a warped cylinder head from a Chevy Silverado and could slide a feeler gauge, the thickness of 3 sheets of paper underneath it. That tiny gap, caused by a simple clogged radiator, was enough to condemn the entire engine.
If you want to see how other invisible forces like fuel quality are silently affecting your car, check out our playlist on engine chemistry right after this. But buckle up, because the #1 way heat destroys your car is the most expensive and the most modern failure of them all.
Number 1. Electric vehicle battery degradation. You bought an EV for its simplicity, but you notice your max range isn't what it used to be. Each year, you're losing more miles than you expected. Here's the thing. Lithium-ion batteries are incredibly sensitive to heat.
While they have thermal management systems, high ambient temperatures, especially above 90 degrees Fahrenheit, accelerate parasitic side reactions inside the battery cells. These reactions permanently consume the liquid electrolyte and cause the solid electrolyte interface layer on the anode to grow thicker.
Trust me, it's like plaque building up in an artery, slowly choking the battery's ability to hold a charge.
A massive study by Geotab, analyzing 6,000 electric vehicles, confirmed that EVs in hot climates suffer significantly faster battery degradation. The first cost is the daily anxiety of losing a mile of range per week. The next is thousands of dollars in lost resale value. The final consequence, out of warranty, is an eventual $30,000 battery replacement.
I saw a first-generation Nissan Leaf from Phoenix that had lost over 40% of its original capacity in just 5 years. The battery health screen was a graveyard of dead cells, grayed out on the display. It looked like a missing tooth in a smile, a permanent, expensive gap that proved it had lived its life in a thermal war zone. Now, fighting this invisible war doesn't require a miracle. It requires discipline. The first weapon is a turbo cool-down.
If you have a turbo, let the engine idle for 60 to 90 seconds before shutdown. This lets circulating oil and coolant carry heat away from the turbo's core, preventing that oil coking we talked about. Your second weapon is proactive cooling system maintenance.
Don't wait for it to overheat. According to AT, cooling system failures are a top cause of roadside breakdowns.
A coolant flush every 30,000 miles removes the scale and corrosion that cause the hot spots that warp cylinder heads.
But the most powerful weapon is knowledge. A $30 infrared thermometer is the single best tool you can own.
Once a month after a long drive, pop the hood and take baseline readings. Check your radiator hoses, the alternator casing, the thermostat housing. Write them down. If you ever see a number that's suddenly 40 degrees higher than your baseline, you've just found a problem.
Long before it can trigger a warning light or leave you stranded, you've spotted the enemy before it has a chance to attack. Now that you know how thermal load damages everything from plastic polymers to lithium-ion cells, the next critical step
is to recognize how that same heat compromises the softest parts of your engine, the seals and gaskets. When a seal fails, fluids begin to contaminate each other, starting a catastrophic chain reaction. Watch our video on fluid contamination cascades
to see the second invisible process that costs owners thousands when it finally fails.